This video is to help you with the classwork for section 5.1.2. How big is it? Describing parts of parts. Our learning target is to use models to multiply with fractions and then to develop the standard algorithm, meaning the normal method that we use to multiply fractions. So when we look at the first one they talk about on 5.9, it says Grant, Oliver, and Sonia were working on this problem below. Jenny's house is 4/7 of a mile from the bus stop. If Jenny had to run 2/3 of the way from her house to the bus stop, what portion of a mile did Jenny run? And they each started by visualizing 4/7 in their own way. So Grant did it with a rectangle, which he broke into 7 parts and shaded 4 of them. Oliver drew 7 circles and shaded 4 of them. Sonia did a number line from 0 to 1 and shaded 4 parts out of 7. So that number line was broken into 7s, and she shaded 4 parts. So we want to think about whether Jenny ran more or less than half a mile, right? And we're going to be going ahead and doing some estimating, but then we're going to be looking at their specific way of interpreting it to figure out 2/3 of 4/7. So we're going to start with Grant's drawing. Again, our goal is to figure out 2/3 of 4/7. He has 4/7, as we said, drawn in this way. He's got the large rectangle, which is broken into 7 parts. He's shaded 4 of them. So this part is already taken care of. Now what we're doing is figuring out what 2/3 of that is. So what we need to do is to break it into thirds vertically so that we can then shade in 2/3. So 2 out of the 3 columns need to be shaded of the section that was already shaded. Okay. So this is taking 2/3 of, or times, the 4/7. Okay. For Oliver's drawing, he has the 4/7 drawn as 4 circles out of 7. So again, we want to know what 2/3 is of that, 2/3 of the 4/7. And I'm intentionally not figuring out the answer for you yet because I want you to see the 3 different methods. So here you would go ahead and break the circles into thirds because we want to be able to do 2/3 of these. And the easiest way to show thirds is to do sort of a peace symbol type scenario. So that was not well done. Let me fix that. And the good news is we really only have to do that or show that in the 4 that are already shaded. We could do it in all 7, but the key is we're looking at 2/3 of these 4/7. So really only need to break these into the thirds. And then we're showing 2/3 of those. And then with Sonia's drawing, she's taken a number line from 0 to 1. She broke it into 7 sections, 7 spaces, which is done by putting in 6 lines, and she's shaded in 4/7. So what we want to do here is look at 2/3 of that. And the best way to do that would be to break each of these parts into thirds. So again, our goal is to do 2/3 of the 4/7. Again, we could go ahead and break it into thirds all the way along, but we really only need to look at 2/3 of those 4/7. So 2 out of 3 of this section, 2 out of 3 of this section, and 2 out of 3 of this section. What you want to do in all 3 cases is go back now and say, how many are shaded out of the total? Because that's going to represent the portion of the mile. So here we have 1, 2, 3, 4, 5, 6, 7, 8 are shaded out of 3 times 7, so 21, 8/21, which cannot be simplified. We know that 8/21 is less than half of a mile. The reason we know that is because half of 21 would be 10.5, and this is a smaller numerator than that. Or another way you could think of it is 8 out of 16 would be 1/2, so 8 out of 21 is less than 1/2. Here we again have 8 shaded out of 21. Now you might not see the 21 as easily since again I didn't go ahead and show the thirds here, but we could break it all into thirds to make that a little more obvious. And then the same thing here, 8 out of 21. What they're looking for you to do is to realize that there's more than one way to visually represent that information. The other thing I think they're looking for you to do is to start thinking about, well, we had 2/3 of 4/7. We know of means times. We got 8/21. So what does that basically tell us in terms of gearing towards the idea of a standard method or a standard algorithm? What do we see is occurring with the numerators? What do we see is occurring with the denominators? So in each case, when we took 2/3 times 4/7, which again is the same as of, we got 8 for the numerator and 21 for the denominator. So what did we notice was occurring to the numerators and to the denominators to get to 8/21? And is there a sort of shortcut that we can think of based on that? All right. Then you're going to do the same idea here. 3/5 of 2/7, 1/2 of 1/10. Again, they want a diagram, but you also are going towards recognizing the standard algorithm, the method that seems to work. All right. I won't do those all for you, but again, they can be done in multiple ways, with the circles, with the rectangle method, with the number line method, whatever makes the most sense to you. All right. And then that they're trying to get at here is that 1/2 of 1/4 is the same as 1/4 of 1/2. When we multiply that the commutative property is true, you can change the order without changing the answer. So they want you to draw a picture that shows that. Start with 1/4 and then take half of it. Start with 1/2 and then take 1/4 of it. And you should find that you get the same results. All right. We will talk about the homework in the next video.